Okay, so the lesson on finance in this unit, it goes with exponential equations. It's not an application of logs. Interest is an example or an application of exponential growth, okay? Like I said, we're going to do the handout and we will also do the workbook for this. For the most part, it is going to be familiar to you, except for part of it, we're going to be changing the base that will be unfamiliar, and that's really the only new thing that you're going to have in this lesson. So before we sort of start, let's just look at this table and fill it in as the initial amount and then the rate of change. So remember that whenever we're in the equation, the exponential equation, y is equal to ab to the x. A, yes, it's the y-intercept of our graph, but it's also the initial amount. So the initial amount you invest, the initial amount of bacteria, the initial amount of the population. And then y is always your final amount. When we're dealing with money, the initial amount of money that you invest, it's often called the principal. Okay, so you're going to see initial amount or you're going to see principal here. The principal amount is the initial amount you invest. So the initial amount for each of these functions would just be whatever the A value is. So we're going to have 1,000 is the initial amount. It doesn't tell me if it's money or bacteria or what it is, but these would be the initial amounts. 300, 750, and 10. The rate of change is either the growth or the decay. So if you take this number, and we'll just write it off to the side, so 1.5, that as a percentage would be 150%. That would be 50% growth. Because remember, we always start at 100% and we're either going to grow or we're going to decay. So if we have a B value of 1.5, from 100%, that would be 50% growth. Does anybody know what 0.8 would be? It would be a decay, but what percentage decay would 0.8 be? 20% decay. Yes. So we'll write it down and then I'll show you how you'd figure out the math if you needed. So that would be a 20% decay. So 0.8, if you needed, convert it to a percentage to think about it a little bit better. So 0.8 is equivalent to 80%. From 100%, if you're going down to 80%, that's 20% decay. It's 50% growth. You always start at 100, yes. So if I said the population is growing by 50%, your B value would be 100 plus 50, which is 150, and we always convert our B value to a decimal, which is where they're getting the 1.5. Okay, this one here, the rate of change, so 1.025, we'll convert it to a percentage. That's 102.5%. If we're starting at 100%, that would be a 2.5% growth. Okay. Percent growth. James, do you know what this one would be for a decay? It'd be a 5% decay. Again, that's 95%. From 100%, that would be a 5% decay. Okay. Let's talk about what compound interest is. So compound interest is making interest on interest. So you put money in the bank and you keep your money in for 1 year. The bank is going to pay you interest. If you then keep your principal amount and your interest in the bank, on the second year, they're going to give you interest on the original money that you put in plus your original interest. So you just make money on money, basically, with compound interest. So it says compound interest. You deposit $1,000 earning 6% per A. What this is going to mean in math is per annum. Okay, so if you see like slash A, that's going to be per annum. Do you know what an annum is? Yes, an annum is a year. So what's happening? You put in $1,000, they're going to give you 6% interest on that $1,000 every year, compounded annually. So annually just means you're going to get your interest at the end of the 1 year. Okay, so you put your money in at time zero. You put your money in at time zero here, and then at the end of 1 year, you're going to get your interest. Calculate how much money you would have at the end of. So 1 year, 2 years, 3 years, and T years. So for 1 year, we'll do our work down here. Remember that it's y is equal to ab to the x. Y is equal to our initial amount invested is $1,000. Our b value, 6% growth is going to be 106%, and as a decimal, that would be 1.06, right? So our b value would be 1.06, and then this is going to be our number of years. So at 1 year, if we make 6% on our money, we put 1,000 in, we're going to make we're going to make 6%, and then after 1 year, the bank is going to pay us 1,060. So they're going to pay us $60 interest. Okay. With currency, you always need to have two decimals for currency. Okay, so some students would look at this and they'd say, we're getting paid $60 a year. So at the end of 2 years, it would be $1,120, right? But that's not how compound interest works. Now what they're going to do is they're going to pay us interest on that $60 as well. So at the end of 2 years, it's going to be $1,000 was our initial deposit. We're making 6% a year, and now I'm changing, we're at 2 years. So watch how we'll have slightly more than $120 interest. So if I go back up to my equation and I change this to 2, we're going to have $123.60 because they paid us now interest on that $60 that they gave us. So instead of having 1,120, we've got 1,123.6. Now remember, because it's currency, it's going to be 1,123 and 60 cents. At 3 years, we do the same thing. And if we keep our money in for 3 years, they're gonna pay us $1,191, and we'll put 2 cents. And then at T years, we don't know what T is. What they will pay us is our initial investment compounded annually at 6% for however many years we keep that investment in. Okay. Yes. Yep, how I got that 1.06 is they told me that I'm earning 6% interest, so that's like a growth. So it's going to be 100% plus 6% is 106%. And then from there, I convert that. My B value is always a decimal, so 1.06. So like, let's say you have an 8% interest rate, it'd be 1.08. A 12% interest rate, 1.12. If you lose money, like the value of a car, you lose 5% a year, 0.95, 100 minus 5. Okay. Okay, so what happens with compound interest though is some banks will pay you annually, which is once a year. Some banks will pay your interest semi-annually. So semi-annually, if you see this word, do you know how often you're going to be getting interest? Yes, twice a year. So if you see the word semi-annually, that's going to be your interest payments will be 2 times a year. Okay. Then we're going to have to actually change our base if it's semi-annually, or they might pay us interest monthly. Every month they're going to give us interest every single month, and we'd have to change. That's going to be 12 times a year, or they could say they're going to pay us quarterly interest, which would be 4 times a year. So semi-annually, they have 2 interest periods per year. So what happens would be essentially the following. At year 1, we're going to have our initial investment. We're going to have our base, and I'm going to show you how to calculate the base because the base is going to be slightly different when it's not annually. And then what we do up here is if we're in for 1 year, how many payments of interest are we getting in 1 year? 2. So this would be a 2. If we have our money in for 2 years, okay, so y is equal to a, b, how many payments would we get in 2 years? 4 payments. In 3 years, it would be a base 6. And in t years, it would be a, b, 2 times t. Okay, so however many years we're in for. And the 2 comes from, this 2 comes from 2 interest payments per year. Okay, this would be the number of years, and we're getting paid basically twice a year for the interest payments. If they were going to pay us quarterly interest payments, this would be a 4. If we were going to get monthly interest payments, this would be a 12. And we're going to have to adjust the base, and I'll show you adjusting the base in a second. Okay, so what would your formula look like if the investments were compounded quarterly? So it's going to be y is equal to a, b. Now remember, b we're going to be adjusting, and I'll teach you how to adjust that. But quarterly payments would be you're being paid 4 times every year. Monthly payments would be y is equal to a, b. There's 12 months in a year, so 12 payments of interest every year. Okay. Okay. So for compound interest, there's a new formula. And unfortunately, the new formula is not on your formula sheet. The formula sheet that you'll always be given is y is equal to a, b to the x. I'm going to show you this new one and then how you could adjust it to make it look like this. So the compound interest formula, instead of y, we use a. And a is like your final amount. That's equal to, instead of the variable a here, they're going to use p, and that's your initial amount. That's your principal. Then the b value is where we have to do a bit of work. Now remember that interest is always growth. We're always getting, it's plus from our 100%. So 100% is 1 plus, and then what it's going to be r over n. Okay, so what r is our rate. So for example, 6%. And then n is the number of compounds. So if we are being paid annually, that would be 1, once a year. If we're being paid interest semi-annually, n would be 2, twice a year. If we're being paid interest quarterly, n would be 4. And then it's n times t, the number of compounds times the year. Okay. From this, we will get our base. And we'll do lots of like practice where we will get our base. Okay, let's look at this example. You invest $2,300, earning an interest rate of 6% um, compounded monthly for 7 years. So I'm just going to move this down for a second. Okay, so let's figure out a couple of things here. 2,300, that is our initial investment, or it's our principal. Okay, 6% is our rate. So our rate is 0.06. Then it says it's going to be compounded. We're going to earn interest 6% monthly. They're going to compound it monthly. So because they say this word monthly, what that means is my compounding periods, which is N, how many times am I going to get, like how many times is the bank going to pay me interest? 12. Every month they're going to give me a bit of interest. And then this is my time for 7 years. Okay, so what does this look like? Our formula is going to be A is equal to how much we put into the bank, 2,300. We need to figure out our B value. Our B value is not going to be 1.06. Okay, it won't be that. It'll only be 1.06 if they're giving us interest once a year. But they're giving us interest 12 times a year. So it's going to be 1 plus, it's whatever your rate is, divided by the number of compounding periods. We're going to get interest every 12 times a year. And then it's going to be n times t, which is 12, like 12 times a year, times however many years. And I'll just put actually t here for now. So A is equal to 2,300, and we've got to figure out what this B value is. So the B value is going to be 1 plus 0.06 divided by 12. My B value is 1.005, 12 every year. It can't be 1.06 because then, like, they can't pay me 6% interest every single month, right? So they're dividing that 6% interest over the 12 months is what they're doing. And that's why we divide that 6% over the 12 months. Okay, so how much money would we have earned in 7 years? A is equal to 2,300, 1.005, 12, 7 years. Amount earned is going to be 2,300, 1.005 power of 12 times 7. $3,496.85. Now, earned is what you made. That's not what I made, right? Because I initially put in $2,300. How do you figure out what you earned? Yes, you subtract what you earned is going to be, after my interest, I have this much. I put in 2,300. So what's the difference between those two numbers? So 3,496 minus my initial investment is going to be, this is how much interest you made in 7 years, $1,196.85. So 1,085. That number there is the interest earned. Okay. Okay. How many years to the nearest tenth until you triple your investment? So I invested 2,300. What would tripling that be? What's that? Yep, 6,900. So that's my final. We're going to figure out how many years, that's my initial investment, how many years is it going to take to triple that, which would be 6,900. That's going to be, it's my A value times my B value. Remember, we got our B value of 1.005. We're getting paid, we're being compounded uh, 12 times a year. And then I want to figure out the number of years that it's going to take to triple my investment. So let's get rid of that 2,300 by dividing both sides by 2,300. And you're going to get a 3 here, right? 1.005 12t. You guys, what I want to say is when they do this like triple or make 5 times your money, you don't have to actually ever even figure this out. You could just put a 3 here and there's an invisible 1 here. That would be tripling, right? You've got like $1 and you're tripling it. If I said how much time would it take to get 5 times your money? Well, put a 5 here and there's an invisible 1 here, right? So we didn't have to do this. Okay, let's figure out what 12 is, or sorry, what t is. So let's take the log base 1.005 of argument 3 is equal to 12t. T is equal to, I'm going to calculate what this is, and then I'll divide it by 12. So log of 1.005, 3, that number divided by 12 is going to be, it said to the nearest tenth of a year, that would be 18.4 years. After 18.4 years of sitting there, your money would triple. Okay. Okay, let's do a couple diploma questions and then we'll do a couple questions in the workbook just to get more practice. It's the base that students sort of will have a hard time figuring out. Okay, this is not a money question. So you don't have to do a lot of work unless it's a money question for the base. Let's write our formula. Y is equal to AB to the X. So this is an old diploma question. A town's population is increasing at a constant rate of 2.6% per year. So what that means is we just do our normal calculation for base. So that would be like 100% plus 2.6%. That would be 102.6% is our growth. And then convert that to a decimal. Our B value is going to be 1.026. That's what my B value is going to be because it's per year. Okay, so they said that per year. This year on January 1st, the population of the town was 16,000, which is going to be my initial population. And the minimum number of years that it's going to take the town's population to exceed 20,000, that's going to be my final population. Okay, so final population would be here, 20,000 is equal to the initial population, 16,000. Our base was 1.026, and we're figuring out X, which is our number of years. So get rid of your 16,000 by dividing both sides by 16,000. 20,000 divided by 16,000 will give you 1.25 is equal to 1.026x, and then turn that into a log to solve. Log base 1.026, argument 1.25 is equal to x. See what you get on your calculator. And then there's two answers that most people are going to figure out which one they need to circle. So decide if you know which one it would be. Okay, so we got to decide, are we circling 8 years or are we circling 9 years? 9 years. Jonathan, do you know why? That's right. And how you would check it on your calculator is if I plug in 16,000 was my initial, my base 1.026, after 8 years, my population is just below 20,000. So it's not 8 years because they said how many years will it exceed 20,000? That's going to be 9 years. So I could, to show that it'd be 9 years, at 9 years, whoops, I've exceeded. Okay, so that's why the answer would be B. Okay, let's do an interest question. Even though it's going to be compounded annually, I want you to set it up. So let's just write A is equal to our principal amount. That's just Y is equal to A. Same thing. Remember, it's 1 plus whatever the rate is divided by the number of compounding periods, and then N and T. Okay, Joe invested 4,500. At the end of 12 years, the investment has doubled in value. So doubling in value, Jack S, what do you want me to put for doubling in value? Even though I could put it 2, but if it's 4,500 initial investment, no, doubling it. He's going to double that number. Jackson, do you know what it would be? A, what's the final amount? Yeah, 4,000, it's 4,500 is the initial. 9,000. Okay, doubling would be 9,000 because it says the investment has doubled. The initial was a principal amount, it'd be 4,500. 1 plus, what we're figuring out for this question is what is the rate? Okay, now, what would my N be for this one? What's my number of compounding periods if it's compounded annually? N would be 1. So this is going to be, make it simpler for us, N is equal to 1. And then 1 times T. Okay, so I could clean this up a little bit by, let's divide 4,500 by each side. We're going to get 2, so doubling. So there's my 2, it's doubled. Then I'm going to have 1 plus, this is going to be my rate, that's what I'm calculating, and I've just got T here. Yes. Yes, it would be. T is 12 because what we're trying to figure out for this question is what was the rate? Like what was the interest that we're being paid? So you're right, T is equal to 12. What would you guys do for this? You don't need to do logs because That's the same thing as raising both sides to what power? 1 over 12. Yes. This is 12 over 1. I need to get rid of that because I need to isolate my r. So I'm going to raise this to the power of 1/12, and I'm going to raise this to the power of 1/12. This would cancel. I'd be left with 2 to the 1/12 is equal to 1 plus r. My rate is going to be 2 to the 1/12 minus 1. That's going to be my rate. So 2 to the power of 1/12. Oops, I'm missing a 1 here. That guy minus 1 is going to give me that. What percentage is that? Yeah, and I think they want it though to the nearest hundredth of a percent. So this is my rate, but it was basically 6% a year, but to the nearest 100th, it would be 5.95% is what they're paying yearly interest. Rate is 5.95%. Okay, let's do one more question, and then we'll do a couple more, like I said, interest questions from the book, and then I'll give you your homework. Write your equation. Y is equal to AB to the X. In 1996, a particular car was valued at 27,500. Its value decreased exponentially each year afterwards. It's decreasing by 24% per year. So the initial value of my car is 27,500. What would my base be? If it's going down by 24% a year, how did you get that? 100 minus 24 is 76%, which is correct. And then convert that to, yes, so this would be 0.76. It's going down 24% every year. And we're not even calculating anything. We're just choosing what the answer would be. And it would be C. Okay. Okay, open your books to page 244. We'll do 2 more questions, and then it'll be enough. Okay. Uh, 244. So A, and we'll do class example 3. A is your final amount. It's the same thing as Y. That is equal to your principal amount, which is your A value, 1 plus. Earning interest is always going to be a growth. It's the rate. So are we getting 5%, 6%, 7% per year? N is your number of compounding periods. N times T. $7,000 is invested. That is going to be your principal amount. You're going to invest that for 6 years. That's the time. It's compounded quarterly. That's going to be your number of compounding periods, which is 4. If they give you 5% per annum, 5% per year, that's your rate. Okay. So determine, you put in $7,000, how much are you going to have 6 years later? So the amount is equal to 7,000 was put in. We got to figure out our B value. It's going to be 1 plus. Now remember, we're not making 5% every quarter. We're making 5% a year, and we're going to divide that over 12 interest payments. Okay? So rate is 0.05 divided by 12. The number of compounding periods was 4, and we're doing this for 6 years. Let's make sure we get the B value correct. So, oh, you're right. What am I doing? Two things. What do I need to fix? This guy, it's not monthly. That would be for monthly. So that I need to fix. And what's the other one I need to fix? Just that? Okay, let's figure out what the B value is. Amount earned is going to be 7,000. Our rate, we're getting 5% a year, but we're getting paid in quarters. So it should be 1.0125. And then there's 24 different times that they would be paying us. So 7,000 times our B value to the power of 24. Okay, so the amount would be, after 7 years, so we put 7,000 in, and then our bank account's going to have $9,431.46. That's going to be the amount of our investment after 6 years. Remember though, that's how much we're going to have at the end. We went from 7,000 to 9,400. That's not what we earned. If they ask what did you earn, it'd be 9,431 minus your initial investment. That's going to give you your interest made in those 6 years, which would be $2,400 interest. Okay. Let's do number 5. Okay, let's write our formula. She invests 8,000. That's her principal. Account which pays compound interest 6% per annum. So my rate is that compounded monthly. What would N be for this one? 12. How long would it take in years and months for her investment to double in value? Okay, so you guys, instead of doing 16,000 and 8,000, let's just do a shortcut and put a 2 here. That would be doubling in value. Again, I could do 16,000 and 8,000. You divide out the 8,000, you're going to get 2. So I'm just kind of skipping a step. 1 plus the rate divided by 12, 12 t. So I'm figuring out what t is. Let's figure out what our base is. So 1.005. So type that log on your calculator, get your answer, divide it by 12, and you're going to have how many? Wait a second. Time. What are you guys getting for T? 11.7. Here, just let me punch mine in. $11.58 years. 58 years. Do you know how you would convert that 0.58 years to months? What would you do? Because I want to know how many years and how many months. So this would be 11 years. How do you convert 0.58 years to months? So we have 0.58 years times, if I want to figure out how many months that would be, there's 12 months in 1 year, right? So I would take that decimal of 0.58 and you'd multiply it by 12, and that would give you how many months 0.58 is. And what are you getting on your calculator? Like, what would you round that to? Yeah, it's 6.97. The book rounded it to 11 years and 7 months, but you're right. If we went to 7 months, we'd be just under. So 11 years and 6 months. Okay, is how you would do that. What's that? For it to double, right? So if you put, say that again. Yeah, we would be over. Oh yeah, we would be over if we go up to 7 months. So this would be 7 months. Okay, circle your homework, and I'm going to tell you two different sort of areas of work that you could practice. So 5, 7, 8, 11. 5, 7,